So here we go with the new syllabus, GCSE Computer Science, AQA, and we're looking at paper 1. This is the paper that focuses entirely on programming and algorithms and all that jazz. So starting as always with question 1. Let's have a look at the algorithm here. An algorithm that uses the modulus operator, so modulus we'll come on to and remind ourselves about later, has been represented using pseudocode in figure 1. Okay, let's have a look at what's happening here. So something's being put in by the user into a variable I, so it's being assigned to I. If I mod 2 equals 0, now mod, in this case they've actually told you what mod means down the bottom here, so it's always worth reading the whole question before you start worrying. Mod means the remainder after you've done a division. So 14 divided by 3, 3's into 14 go 4 with 2 left over. So the answer is 2, the remainder. 24 mod 5, 5's into 24 go 4 with 4 left over. So the mod is 4. So if I mod 2 equals 0, in other words, there's no remainder after you divide by 2. So in other words, they're saying, is this an even number? So if I is an even number, output I times I squared. Otherwise, output I. So even numbers output I squared, odd numbers output the number that's put in. Okay, let's move on here. So questions. Shade one lozenge that shows the line number where selection is first used. Selection. Selection is where you make a decision between possibilities. So what you're looking for is if. Selection always means if. Where is if used? If's used here in line 2. So the answer is 2. Let's move on. Shade one lozenge that shows the output from the algorithm in figure 1 when the user input is 4. Now you remember from what we said before, the check here, I mod 2, you're dividing by 2. If the remainder is 0, that means it's an even number. Well, input is 4. 4 is an even number, so it means that this is going to be true. So we output I times I. 4 times 4. 4 times 4 is 16. So we'll shade 16 there. 1.3. Shade one lozenge which shows the line number where assignment is first used. First, not just any old assignment. Assignment in pseudocode by AQA is done using the arrow. So assignment is used here. When the user inputs a value, it's assigned to the variable I. So it's in line 1. Line number 1. Shade there. Don't forget, by the way, that if you do make a mistake here, you can put a cross and then shade a different one. Shade one lozenge that shows the line number that contains a relational operator. So a relational operator is an operator, a symbol, that is used to show two things being compared to each other. Let's have a look. So where is something being compared to something else? Well, the answer is here in line 2. We're comparing, does I mod 2 equal 0? Equal is a relational operator. Equals, less than, more than or equal to, less than or equal to, or so on. So the answer is line number 2. And on we go. They will do this. They'll always repeat something if you're going on to another double page spread. So in this case, here we are. Shade one lozenge to show which of the following is a true statement about the algorithm in figure 1. Now, even if you spot one that looks true, it's wise to go through and check all the others to make sure they're false. This algorithm uses a Boolean operator. Now, a Boolean operator is where you use and, or, not. Is there an and or a not in here? No. So that's false. This algorithm uses a named constant. there are no constants. There is a variable I, but that's it. That's all that's used. This algorithm uses iteration. Iteration, looping, repetition, no. It only uses selection. So no, no, no. So by elimination, we think that D must be the answer. Is that true? The algorithm uses the multiplication operator. So that's one of the arithmetic operators. Yes, it does use multiplication. There it is. There's multiplication there. So D is the correct answer. Figure 2, excuse me. Figure 2 shows an implementation of the algorithm in Figure 1 using the Python programming language. Here we go. So what's the difference here? Notice that the user input has got an int because we're putting in a whole number. Sorry. Percent is the modulus operator in Python. Double equals for equality. Remember, equals is assignment, double equals. And print is used for output. If and else, not forgetting our colons. Now the program in Figure 2 needs to be changed so it repeats 5 times using definite iteration, count controlled. So it's got to repeat 5 times and it has to use definite iteration. Well, let's look at the options available to us, and we've got to choose one of them. So we're told it has to be definite iteration. Well, definite means we know how many times it's going to repeat before we start. Do these all of these use definite iteration? No. For is definite iteration, while is indefinite iteration. So we can immediately reject C and D. So only A and B use definite iteration. Now, does it repeat 5 times? Well, the only difference between the two algorithms is here. What is the range used? The numbers go from 0 to 5 or 0 to 6. Now let's think, if it repeats from 0 to 5, it's going to go 0, 1, 0, 1, 2, 3, 4. Then when it gets to 5, it stops. Remember, the last number is when it stops, not to be used. It just tells it to stop doing it. For this one, 0 to 6, it'll do 0, 1, 2, 3, 4, 5. Then when it gets to 6, it stops. We're told that it has to repeat 5 times. So how many times? 1, 2, 3, 4, 5 times, 0 to 4. 1, 2, 3, 4, 5, 6 times. So only the first one repeats 5 times. So that is the correct answer. And over we go. Now, big algorithm. Let's work our way through this one. Number 2. Calculates the delivery cost for an order from a takeaway company. So user inputs an order total. Now, what kind of variable is order total? Let's have a look down. So it's expecting, if you look down here, order total 0.0. So we're looking at a floating number. Delivery distance is also taken in, and in this case, when you look down, you'll see it's using integer values. Delivery cost is set to be 0.0. In other words, it's set to be a float value. Message 1, minimum spend not met. Message 2, delivery not possible. So these are 2 constants that are used within the program. If delivery distance is less than or equal to 5 and order total is more than 0.0, so here are 2 conditions that both have to be met for this next part to be done. If those aren't met, then we output message 2, which is it's not possible. So if your order total is not bigger than 0, so in other words, if it's 0, if you haven't ordered anything, you can't have it. And if the delivery distance is bigger than 5, then you can't have it either. So either of those 2 things are wrong, then it outputs that. Okay, so let's assume that we are allowed to have a delivery. If the order total is more than 50, then we set delivery cost to 1.5 and we output that. Otherwise, else if order total is more than 25, so we've eliminated the fact it's more than 50. So if we say it's more than 25, then clearly that's between 25 and 50. So we've already got rid of the idea that it's more than 50. So else if says, if that didn't work, try this. Then we do some fancy footwork with that and output the delivery cost there. Otherwise, we output message 1. In other words, you've got to have an order total of more than 25, otherwise you haven't met the minimum spend. Right, let's look through the questions. So, use figure 3, complete this table. Order total is 55.5, delivery distance is 2. Okay, let's have a look and see what happens. So, the order total is 55.5. Is the order total bigger than 0? Yes, it is. Is the delivery distance less than or equal to 5? Yes, it is. So we can, that's fine, that's met. Is the order total bigger than 50? Yes, it is. So the delivery cost is 1.5. So we output 1.5. Next one, the order total is 35.0 and the input value, delivery distance, is 5. Let's have a look. So, is the delivery distance less than or equal to 5? Yes, it is. It's equal to 5, so we're still okay. And order total is bigger than 0? Yes, it is. Is the order total bigger than 50? No, it's not. So we can't do that bit. We move on to the else if. Is the order total bigger than 25? Yes, it is. It's 35. Delivery cost is order total divided by 10. Well, the order total was 35, so 35 divided by 10 is 3.5 times by 2. 3.5 times 2 is 7. So we output the output. Now remember, it's a real value, so 7.0. So it's a floating point value. How many possible values the result of the comparison delivery distance is less than or equal to 5 could have? How many possible answers are there to this statement? Well, there are only two possible answers. It's either true, the delivery distance is less than or equal to 5, or it's false, it's not. So there are two possible values, true and false. It's a Boolean statement. Let's have a look at the next question. State the most suitable data type for the following variables. Delivery cost. Well, let's have a look at delivery cost again. When we look at delivery cost, we see it's set to 0.0. So that means it's a float data type. It's got a decimal part. And message 1, well, message 1 is writing, so message 1 is a string. And then it's a free hit. State one other common data type that you have not given in your answer to question 2.3. Well, we can't use float or string again, so we could use integer, we could use char for character, or we could use Boolean. Any of those are acceptable for 1 mark. And we continue. Okay, now this time we're not dealing with pseudocode. In the new specification, they will give you questions in a programming language. So in this case, we're working with Python. So we've got a Python program that calculates car park charges. The user inputs their car registration and the length of the stay. Program outputs the charge. Line numbers are included, blah, blah, blah. Charge is assigned the value 0. Then car reg, this is where you enter your car reg, so that's input in, so the person inputs that. If the length of car reg is greater than 8, in other words, you've typed in a car reg that's too long, display message is not valued, and ask. In other words, keep asking until the person puts in a car reg that is 8 characters or less. Hours equals int input, right, input your stay in hours, so it's an integer value, int. If hours is less than 2, then you're free. The car park is free. Otherwise, charge equals hours times 2. In other words, it's £2 per hour. Then you print out the charge. Okay. Rewrite line 4 to concatenate the car registration with the string is not valid. So you see there it says display message equals is not valid. Line 4. Well, it's just saying is not valid. You need to stick the car reg onto it. Concatenate means to stick two strings together. So we need to store, so we need with the string and store the result in the variable display message. So instead of just saying display message equals is not valid, we write display message equals, we're assigning, and then we put the variable car reg and plus concatenates with the string is not valid. That will stick together the car reg that's typed in with the word is not valid, so it'll output whatever car reg it is not valid. The charge for parking for 2 or more hours is changed to include an additional £2 fee. So hours times 2 and 2 more pounds. Rewrite line 10 to show the change. Your answer must be written in Python. Okay, let's look at that. So at the moment it says charge equals hours times 2, and we've got to put 2 more pounds in. So all we need to do is write charge equals, so we're assigning hours times 2 plus 2. There we are. That's added 2 more pounds on to add to our charge. Moving on to question 4. Now again, we're dealing with Python. The 2 Python programs in figure 5 output the value that is equivalent to adding together the integers between 1 and an integer entered by the user. So if the user enters the integer 5, it will add up 1 plus 2 plus 3 plus 4 plus 5. If you type in 10, it will up to plus 10. For example, if you enter the integer 5, it would output 15 because that's 1 plus 2 plus 3 plus 4 plus 5. Okay, now let's look at what we could do. You could do a loop that will just keep adding 1 and keep adding it on over and over and over. Or you can use the fact that if you remember from your maths, your nth number of the sequence, then you can use a formula that actually multiplies the number by itself plus 1 and then halves it, and that'll give you the answer. So shade one lozenge to indicate which of the statements is true about the programs in figure 5. Both programs are equally efficient. Program A is more efficient than program B. Program B is more efficient than program A. Well, let's think about this. Let's say you typed in the number 10 to start with. Well, in that case, you would type in 10 here, total would be 0. Then you would go repeat the for that. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You'd be doing that 10 times. Whereas here, you've only got to, you'd have the same 3 calculations every time. There's no looping, there's no repetition. So program B will use less steps than program A. So program B is more efficient. And what's the reason for your answer? You can say something like program B will execute faster. There's 1 mark. Because it uses less steps. 2 marks. On we go. Number 5. A programmer has started to write a program using Python. The program is shown in figure 6. Here it is. The program should generate and output 10 numbers, each of which is randomly selected from the numbers in a data structure called numbers. Here we are. There are the numbers. For example, random.randrange, it uses the random module, random.randrange 0 to 8 would generate a random integer between 0 and 7. It's that thing again whereby the number at the end tells you not what the last number is, but the number that will make it stop. So it works between 0 and 7. One possible output would be where it chooses 10 random numbers out of that list. Okay, the program shown in figure 6 contains a syntax error. Yep, if you spot, there it is. There's the syntax error there. Should have a bracket there. So, shade 2 lozenges to indicate the statements that are true about syntax errors. Well, let's go through them and see if they're true or false. A syntax error can be found by testing boundary values in a program. No, that's how we check a logic error, to find out whether it's working properly. A syntax error is a mistake in the grammar of the code. Yes, that's true. Syntax is where you've written the program using incorrect language. A syntax error is generally harder to spot than a logic error. No, that's untrue. Syntax errors stand out like a sore thumb because the program won't run. Whereas a logic error, the program will run, but it's just, you've got to find in the middle of it why it's not doing it properly. A syntax error will stop a program from running. Yes, if the code doesn't actually make sense, if it can't be understood by the computer, it'll stop it running. Now let's just check the last one to make sure we've got the correct two. An example of a syntax error is trying to access the 5th character in a string which only contains 4 characters. No, you're still using the correct language of the program. It's just that you're trying to find something that doesn't exist. And again, that's another logic error. So these two represent syntax errors, B and D. So moving on to look at the program in figure 6 contains a logic error. Identify the line number that contains the logic error and correct this line in the program. Okay, let's see if we can spot it. So, working through here, well, import random, that's all right. Numbers there, that's fine. There's your list there. Count equals 0. We're going to start counting at position 0. Yep, that makes sense. Going to start there. While count is less than 10, yep, we want 10 numbers, so that's working fine. Count is count plus 1, so each time you use this, you're going to count up plus 1. Okay, fair enough. Now let's see. So we will have gone around this while loop and we'll have counted 1, then 2. Yep, that's fine. Number equals random dot rand range 0, 8. So we're going to pick out a number between 0 and 7. 0, 1, 2, 3, 4, 5, 6, 7. Yep, that's right. Print numbers count. Hold on a minute, that's not right, is it? Because it's going to pick the place in here, which is the count. But that means the first one will pick out place 1, then place 2. It won't be finding a random one. It'll be finding, and then when it gets to here, when it gets to number 9 or number 8, it's going to fall off the end. That's not going to work at all. It's not count we want to use. It's number. Because number is the random position in the list that we want to find. So there's our mistake. It's in line number 7, and the corrected line should be print numbers position, not count, position number. The random number that we've chosen for where we want to find that number. Oops, there we are. What type of data structure is the variable numbers? Well, numbers is there. What is that? That's a list. So we write list or array, but list is what we call them in Python. Question 6. Right, now we're moving on to a bit more about program design. So a program is being developed that allows users to rate and review movies. A user will enter their rating out of 10 and a written review for each movie they have watched. Computational thinking skills are used during the development of the program. I would hope so. Define the term abstraction. What does it mean? What does abstraction mean? Well, abstraction is removing unnecessary detail. So we're only interested in knowing what it is that we need to actually put into the program. We're not interested in what color things are or whatever, or what they look like. We're only interested in the actual ratings and reviews of the movie. So we're going to remove unnecessary detail to solve the problem. Now we've got a diagram here to represent the decomposition of the program. So it's been broken down into smaller parts. Now this is where you have to read carefully. A user will be able to register, log in, and log out of the program. Register, log in, oh, hello, something there, log out. Right, the registration process. When registering, a new user will enter their details before confirming their email address. Registering the new user will enter details before confirming their email address. Complete the decomposition by stating what should be written in boxes A and B. Well, we were told there were 3 stages. Enter details, there were 3 stages: register, log in, log out. Register, log in, log out. B is log out. And when registering, we were told enter details and confirm users. Right, so that was nice and easy. So A was confirm email address. Notice this was just a matter of reading what it said. There was no great computational skills required, just a matter of reading. And B was the ability at the end to log out of the program. Just log out will be quite sufficient. There we are. 2 marks in the bag. Right, now time to write a Python program. Now this is new in this new specification. We have to be able to write Python programs actually on the exam paper itself. So you need to know your Python syntax, and obviously you won't be able to check them. The first one will be generally reasonably simple. Write a Python program to check if an email address has been entered correctly by a user. Your program must get the user to input an email address, input, right? Get the user to input the email address a second time. So we input the email address, we input email address 2. Fine. Output the message match and output the email address if the email addresses entered are the same as each other. Output the message do not match if the email addresses entered are not the same. Right, we've got some clues there. We've got 2 inputs, and we're told we've got input, input, and we've got an if. Okay, so that's given us our clue. So we're going to need sensible variable names. So we're going to start off with, I think we're going to call the first one email 1 equals input. We could put a little message in there, please enter your email address. You don't have to. Save yourself the time and bother. Second time, input email 2. There we are. Email address is typed in twice. Now we've got to check them by comparing if the email addresses are the same. If email 1 is the same as, double equals, remember, for equality, email 2, colon, don't forget your colon, and indent. If they are the same, then we print out the message match. So I'm going to print, notice I'm indenting, and I'm going to print match. Now I could put another one saying if email 1 is not the same as email 2, then print do not match. But of course I don't need to do another if, because if they don't match, if they don't equal each other, then they obviously don't match. So the alternative is else, colon, again indent, print don't match. I'm going to make sure I use speech marks actually, because obviously don't has got an apostrophe in it. Don't match. And that's it. Now don't be spooked by the fact it's got all these lines on here. They always give you far more lines than you need. So that's just in case you get it horribly wrong here and you want to cross it all out and do another one. But there you go, 5 marks for that, just by doing 2 inputs and an if. And that's how we finish at the end of part 1.